today. So I think it's important to kind of review a little bit what we talked about with the brain and neurons and how transduction works, okay, and how we process this information within the brain. So real quick, here's your bell ringer for today. Listen and describe the 3 types of neurons. Where does sensory and motor processing occur within the brain? There we go. There we go. Kiara, did you see Miss Brim yet? No. Okay, you're supposed to go see her at some point today. How about when we finish up, you go see her? Like 10 minutes ago. I didn't know if you went the end of first period or not. So, yeah, when we finish up, just go see her. Yeah, go ahead. Might as well go see her now, I guess. Bless you. All right, let's get to it here. Listen, describe the three types of neurons. So where do we begin? Where do we begin? Give me one of them, Brady. Go ahead. Sensory neurons. Good job. And what are they? What do they do? Okay, so they are receiving the sensory stimulus and sending it to the brain. All right, good. What's another type of neuron? Hadley. Sorry, go ahead. Hadley. Motor neurons. Good job. What do they do? Yeah, good job. Good job. So they're sending that information from the brain to the muscles, to the glands, to the rest of the body. Okay, most of the time reacting to certain stimulus. It's good. And then finally, what was the last type of neuron we talked about? Go ahead, Christian.
The interneuron, it sends signals from one neuron.
Yeah, good job. So interneurons mostly connect these sensory neurons to motor neurons. Okay, this is almost like a bridge in a way. And they're mostly located in the brain. Good, good. So sensory and motor processing, where does that occur? Where does that occur in the brain? So let's start off with sensory information. Where is that process within the brain? Raven, what do you have?
In the sensory section of the parietal lobe.
Yeah, the sensory cortex, right? Okay, that's located in the parietal lobe. So right between parietal and frontal lobe, right? Okay, good. What about the motor? Where's motor information being processed within the brain? Where's that being processed? We have Hadley. Yeah, good job. So the motor cortex behind the frontal lobe. So that is that gap between the frontal and parietal lobe where the sensory information is being processed along with motor information. Does that make sense, guys? Okay, good. So make sure you guys remember the types of neurons. It's important for today, especially with transduction and how this information is being processed within the brain. Okay, and how we're sensing information around us, perceiving it within the brain, making sense of it so that we can react, we can interact with certain stimulus. All right, good, good, good. So terms for today. Pull that up. Go. We got sensation, perception, and transduction. What's up, buddy? You done with this? All right, hurry up, hurry up. All right, what do we got? Sensation. Allison, what do you have?
The process by which our sensory receptors and nervous systems and represent stimulus and
Yeah, good job. Good job. So we'll talk today. The brain actually doesn't interact with the outside world. It does it through sensation, obviously sensing the world around it, and perceiving the information within the brain. Okay, we'll talk about that process called transduction today. So perception, what do you have? Go ahead. Brady, what do you have for perception? Okay, good job. So this is understanding what we are sensing, right? This is the stimulus that is being presented to us and how the brain is trying to make sense of it, right? So that we can react to certain stimulus, so that we can react to certain situations. And we can make a decision off of it based off of what the brain perceives that senses as, that stimulus as. All right, good. Transduction, last thing here. Haley, what do you have for transduction? Yeah, good job. So we talked about the neuron last chapter and how important that was with understanding, okay, how information is being sent from, let's say, the brain to the rest of the body, from the rest of the body to the brain, and how that is being communicated. So with the neurons sending this information, that's how transduction occurs. So transduction is really just receiving these neural messages, this neural information, and the brain is perceiving it, trying to make an understanding of what we are sensing. Okay, does that make sense, guys? Okay, so transduction is really just making sense of what we are sensing, right? And transduction is that information being sent from these neurons as almost like a barcode scanner. Okay, I'm sure you guys go to Walmart, go to self-checkout, and the barcode, you scan it, and for some reason, somehow, the computer knows exactly what item you're purchasing. And that's kind of how transduction works, right? It's really making sense of the data that's being presented to it, right? And the neural messaging, the neural information that's being sent to the brain. Okay. So that is a good example of the barcode scanner. So real quick, let's go through chapter 4. Let's start it anyway. All right, so sensation and perception. So the basics. All right, so we are filtering the world around us. Okay, the brain again doesn't actually experience the world, the outside world. Okay, the brain doesn't understand the senses. We are actually just perceiving the outside world. We're making sense of it the way we can. And not everybody perceives the same things, the same stimulus. Okay. And there's good examples of how that occurs with color blindness, people that are blind, maybe. Okay. People that might be impaired with hearing. Okay. How they understand these senses and how they perceive the outside world and perceive stimulus. So senses, again, we talked about the sensory cortex and motor cortex. Where's that located? Last chapter when we're getting involved in the brain. All right, the sensory cortex is, again, located right behind the frontal lobe and in front of the parietal lobe, along with the motor cortex. And this is where this information is being processed. Okay, how these sensory neurons are sending this information to this location of the brain to be perceived. Okay, and then we can react just so. As the interneurons are connecting this information from the sensory neurons inside where the motor cortex is, the sensory cortex, and how this and interneurons are sending this information into the motor neurons to react to certain stimulus. So with sensory information goes along well with the limbic system, okay, and how we talked about memories and emotion and how we can link a lot of these memory and emotions together. Okay, I know I gave you a certain example. Whenever you walk into, let's say, a restaurant, okay, you smell the aroma, you smell exactly what, or maybe see an item, a plate that you might like. And it just brings you back to memories, right? It brings you back to understanding of exactly how you felt when you ate that item. And it might obviously alter your choice. Maybe you want to try something new, but you know exactly your past memories with the senses that are obviously being associated, the emotions that are being associated with that memory. That's being located here, and like I said, in the sensory cortex, and how the limbic system works well with the sensory cortex. So sensation. So sensation is a process by which stimulated receptor, ears, eyes, you name it, creates a neural message that represents stimulus in the brain, giving rise to initial experience of the stimulus. Okay, we'll talk about other senses as well, other than just hearing, taste, touch, smell. Okay, we'll also talk about vestibular sense. Okay, we'll talk about kinesthetic sense and how that also is associated with our movements. Okay, and in many cases with vestibular sense, this is really keeping our balance. I know we talked about the cerebellum and how that obviously helps with our balance and our posture and our movement, but also vestibular. Okay, this is really just the fluid within our ears. I'm sure maybe if you've seen a boxing match or an MMA fight or something like that, a lot of times these people are knocked off balance, knocked unconscious because their vestibular sense is all out of whack. Right? And it kind of looks like they're wobbling around, kind of floating back and forth. And again, that is being affected. So again, we'll talk about that more in the upcoming chapter. But sensation is really just picking up this stimulus, right? This is something that we're interacting. Our brain isn't interacting with it, but this is sending information, neural impulses to our brain as we're sensing this certain stimulus, whether it's smell, taste, touch, you name it. So our senses, we'll talk about this here soon and how auditory processing works, breaking down the anatomy of the ear and how we are perceiving audio. Okay, and we'll mention also with sight, okay, and how we are picking up certain points of vision and how we're sensing vision, and how we're understanding and perceiving. It's a little weird actually with vision, especially how that is being perceived and how that is being processed all within milliseconds, really. And it's amazing exactly how our brain can process that information and flip the image right side up and side, obviously from both hemispheres of the brain. So we'll mention that here soon. And we already mentioned about the Wernicke's area, right? And how auditory processing and receptive language really is being associated within that temporal lobe, okay, and how we're perceiving audio. So we'll dive into that here soon as well in this chapter. So with perception, okay, this is really just elaborating on our senses and how our brain is making sense of the stimulus that is being encountered and how we are sensing the outside world, and our brain is receiving these impulses through transduction where we can perceive the outside world and make a understanding of what we are sensing. We'll talk about illusions towards the end of the chapter as well, and I think those are pretty cool to dive into and understand, and really understanding some forms of Gestalt psychology and the principles of it. I know we mentioned it in chapter 1, but there's many different types of principles and backgrounds that go along with it, like closure, like proximity, like the law of similarity, right? There's many examples that we can dive into with certain illusions and understanding of really how we associate grouping and organization. All right, so real quick, I'm sure you guys seen this before. What do you see? Two faces or a vase? What do you see, Kiara? What sticks out to you? Okay, so at first, the figure that you see is a vase, but then you kind of associate, you see the faces in afterwards, right? Okay, all right. What about you, Raven? What stuck out to you first? You see them both, but what stuck out to you first?
I was expecting it, so I looked right to the faces. So
Gotcha. All right, so again, figure and ground. We'll talk about figure and ground. And when we're understanding perceiving vision, what sticks out to us first, right? What sticks out as the picture that represents and draws our attention first? Okay, that's really important when understanding vision. Okay, and what is in the background? What is the figure that's it really establishes itself first that we visualize? And again, we'll get into certain illusions where that could maybe alter our perception of what we're seeing and alter what we're visualizing. All right, so sensation perception. Here's another thing I like to do. Just because with our vision, again, it's being flipped upside down in our occipital lobe. We're actually intaking this information and it's actually being flipped in our occipital lobe to making a perception of right side up. Okay, again, we'll get involved in that more when we talk about vision later in the chapter. But this is a great illusion when talking about how these images are being flipped instantaneously in our brain when we're perceiving vision. All right, so what do we see here? Is there any problem with it? Is there, these pictures look similar? What do we think? Well, did they look similar? I had a quick glance at it. No? What was wrong with it, Rave?
one on the left had its eyes misshapen in its mouth.
The one on the left?
Yeah.
Okay. Wait, Haley, what did you see? You said the right one? Okay, all right. One more glance. All right, Haley, you are right. You are right. Maybe not. Maybe not. But anyway, like I was mentioning, when we're visualizing these types of pictures, we are trying to make sense of it right side up. And when you do flip images upside down, it might be hard for us to perceive it just because it's a quick glance. And our brain, again, is flipping this information right side up. They're just flipping it over then. So yes, the left side is actually the correct side. Okay, when we flip it though, it's right side, obviously, with the eyes and the mouth. Okay, oh, totally different there, doesn't it? Yeah, you can definitely depict the difference between the two pictures when we're visualizing it straight up and down. Oh, gosh, she looks mean there. It's like your mother when you kick your brother right in the gut for no reason. Oh, geez. Okay. All right, here's another one. You guys ready? You didn't get to look at it. Okay, ready? Is she frowning or smiling? That's like always the big question with Mona Lisa. This one's a little harder to tell, I think.
Which one's the action movie?
Yeah, look at the differences here. So which one is maybe the correct image?
It's smiling in the left.
What's that? Smiling on the left one. That's what I see too. Okay. Raven? You see something different?
But I mean, she's definitely smiling in the left one, but
Her eyes look different, but I can't tell if it's like.
Oh, okay. Okay, you saw the eyes too. At first, you can't really tell with the eyes with this image. Obviously, these images when they're flipped upside down. But when you flip it right side up, the eyes are way off. Way off. Oh, it's pretty crazy. That one's a little crazy too. But she does look like she's smiling. Kinda. I don't know. She has a resting bee face, I think. You ask me. She must have been angry when she's getting painted. She's being painted. All right. So the big idea here is because we talked about neurons last chapter, it's important to understand how transduction occurs. Okay, with the neuron, it's sending this neural impulses, this neural information, which is being processed where? In the brain. Okay. And the brain is perceiving this information to make sense of the stimulus that's presented to us. Okay. And again, that's the main thing I want you guys to understand with sensation and perception, how this occurs and how we can process this information. And the way we process it, again, is transduction. But it's important, like I mentioned, that we talked about the neuron last chapter and how this information is being sent really from our sensory information, sensory neurons to the brain, connected through the interneurons, and obviously being reflected through the motor. So transduction, we'll talk about transduction with phototransduction, with vision. Okay, we'll also talk about auditory transduction with hearing. And this is just association with hearing at first, which we'll talk about here soon. As we're receiving the sound waves through the ear canal, it vibrates the eardrum. The bones of the middle ear are triggered, which is then connected to the cochlea. The cochlea is then vibrating really this fluid within inside the cochlea, which interacts with hair fibers, okay, that is sending a neural message to the auditory nerve. Then the auditory nerve sends that information, this neural messaging, where? Where is it being processed? Auditory functioning, auditory processing. Where is that being processed in the brain? Allie, do you remember what lobe? Temporal, yeah, good job. And we mentioned about receptive language with the Wernicke's area last chapter. So again, transduction, the sensory process that converts energy, such as light or sound waves, into the form of neural messages. So neural impulses. That's being sent from neuron to neuron. All right, so best way to understand here's with vision. Okay, so this information is being sent through the eye. We'll talk about the anatomy of the eye in this chapter and how photoreceptors are used to obviously transport this information to the optic nerve. The optic nerve is connected to the back of the brain. What lobe is that? Where vision's being processed? Occipital lobe, good job. And this neural messaging is being transformed through transduction, right? This neural messaging, and we are processing, we're perceiving vision. And we'll talk about that here soon. So the process of transduction, like I was saying, this is really just sending this energy, this electrical signal to the brain to be perceived. And like I said earlier with the vocab, it's really like a barcode scanner at a store. Okay, yeah, the barcode scanner, the computer has no idea exactly what item you're going to scan, but with this barcode scanner, it's sending this information, okay, it's sending this data to the computer, and it automatically knows exactly what type of product's being purchased. And that's the same way transduction's occurring within your brain. It's receiving this neural impulse, this neural energy to the computer, and the computer perceives that image, perceives that energy, that impulse, as what we know as the item we're purchasing. And that's a great example, like I said, of transduction. We're doing this, the same thing with our senses, okay, as we're perceiving the outside world. And again, everybody perceives the world a little bit different. Okay, like I mentioned, if you're deaf, blind, okay, if you're colorblind, obviously you might perceive things a little bit differently. Just like Daredevil, right, Raven?
I didn't watch Daredevil.
You never watched it? Oh, okay, never mind. Never mind. Darn it. Darn it.
I mean, I know he's blind, but
Yeah, he senses the world through like sound waves. So it's almost like sonar. So he like taps on something and it sends a sound wave and can see it within, he can perceive it within his brain. Pretty cool. All right, so like I was mentioning earlier with the sensory neurons, interneurons, we talked about motor neurons and how transduction occurs. Okay, it's again being perceived through these neural impulses to the brain. Neural impulses are sending this information to the rest of our body, our muscles, and to our voluntary movements to react to certain stimulus. All right, is there any questions, guys, on transduction? Christian, you good back there? Okay, all right. Where's your iPad, dude? What? What good's it doing there? Huh. We better find it.
yeah.
Holy cow. Holy cow. All right, any questions, guys? Good? All right, that's all I have for today. Transduction, make sure you remember it. Where's the mouse? There it is. Hopefully you didn't